Okay, so my headphones cut off and turned off, and so I had to restart the video because it stopped recording. So essentially, number 14 is just like what we did in the examples of the guided practice. We have a rectangle, A, B, C, D, and then we have E is where the diagonals intersect. Essentially, for 14, it says the measurement of BAC is equal to 7x minus 7, and the measurement of CAD is equal to 8x minus 8. It says find the measurement of BAC. All right, so when we look at this, we could just label BAC, so it'd be right here. This angle is equal to 7x minus 7, and CAD right here is equal to 8x minus 8. So according to the property of rectangles, we know that these two angles add up to 90 degrees. So what we're going to do is go 7x minus 7 plus 8x minus 8 equals 90 degrees. And then we're going to solve for x. Combining like terms, 7x plus 8x is 15x. Negative 8 plus negative 7 is going to be negative 15 equals 90. So then we're going to have 15x minus 15 equals 90. We're going to add 15. So 15x equals 105. We're going to divide by 15, and I believe that is 7. So x is going to equal 7. Now we're going to have to plug that in for BAC. BAC again, the measurement of BAC is equal to 7x minus 7. So what I'm going to do is going to go 7 times 7 minus 7. I'm just plugging it in. So it's going to be 49 minus 7. And essentially that's going to give us 42 degrees. And let me see if that is correct. Yes, that is correct. Awesome. So number 15, it's the same type of problem. It says, I'm just going to erase this portion. Number 15 says, if the measurement of ADB equals 8x and the measurement of BDC equals 3x minus 9, they want you to find the measurement of DBC. So again, we're going to just go to this diagram and label. So ADB, so right here, it's equal to 8x. And then it says the measurement of BDC, so right here, is equal to 3x minus 9. It says find the measurement of DBC. So DBC. So it wants to find this measurement right here. So this is kind of like a two-step process. We're going to do exactly what we did last time. We know that these two angles right here add up to 90 degrees. So we're going to have 3x minus 9 plus 8x equals 90. We're going to combine like terms. 3x plus 8x is 11x minus 9 equals 90. We're going to add 9. That means 11x equals 99. We divide by 11. X equals 9. So we're trying to find this angle. We know that this angle is congruent to 8x because remember the properties we talked about when we did proofs last unit and the unit before that. Essentially, these two angles, angle ADB and angle DBC, are alternate angles, alternate interior angles. And so that means that 8x equals the angle that we're looking for, angle DBC. So what I'm going to do is I'm going to plug in 9 in for 8x, and that's going to give us 72 degrees. So since the measurement of ADB is congruent to the measurement of DBC, and we know that this is 72 degrees, that means that angle DBC is equal to 72 degrees as well. Okay, so now we're going to move on to problem. I'm going to skip 16 because we've done a lot of these problems in the guided practice portion. And so because I have class in less than 5 minutes, I want to at least get problem 20 and 23 completed. So problem 20 is a proof. And essentially, we have a rectangle and it's labeled V, W, X, and Y, and Z is right here. And then it says given V, W, X, Y is a parallelogram triangle X, Z, Y is isosceles and triangle VZY is congruent to triangle WZX. And it says prove VWXY is a rectangle. All right, so what we're going to do again is write two columns. This is a two-column proof where we're going to have our statements and we're going to have our reasons. And the first thing we want to write down is what's given. We're going to say VWXY is a parallelogram triangle XZY is isosceles and triangle VZY is congruent to triangle WZX, and it's given. And then I don't know what the final step number is, but we write down at the bottom VWXY is a rectangle, and it's because that's what we're trying to prove. So the first thing we want to do is we know that VWXY is a parallelogram. So VWXY is a parallelogram. So that means that these opposite sides are parallel and they're also congruent. So we can put that. And then it says triangle X, ZY. So X, ZY right here is isosceles. So that means that this this portion, YZ, is congruent to this portion, ZX. And we know that VZY is congruent to WZX. So these two triangles are congruent. So that means that they have congruent parts. So again, so VZ and WZ are congruent. So since I have class right now, I'm going to pause this and then have another video that continues on to problem 20 and also 23. I'm sorry about having to break up the video, but I have class in less than a minute. So I will finish this problem and also problem 23 and post it to YouTube later. Thank you so much, and I'll see you in class.